So chapter 2, force and motion, part 1. So we have 2.1, linear motion. So the first point, distance is the total length traveled by an object. The SI unit of distance is meter, m. It is a scalar quantity. So I hope you still remember scalar quantity means a quantity with magnitude without direction. Okay, so let's say example for distance. Okay, so example. If you have an object that move, let's say this is 0, move 5 meter to the right, then after that U-turn, come back to here, 2 meter. Okay, so if you want to find the distance, so we just need to find out how much the object traveled altogether. So from here to here, 5 meter. From here to here, 3 meter. Okay, so the distance is equal to 5 meter plus 3 meter, so equal to 8 meter. So that is how we get the distance. Okay, now let's see number 2, displacement. Displacement is the shortest distance between the initial position and final position in a specific direction. The SI unit of displacement is meter, m. It is a vector quantity. So I'm going to use this as my example again. So if an object traveled 5 meter to the right and then 3 meter back, so I want to find the displacement. So displacement, you just need to care about the initial position. So initial position, let's say I use blue color, this point at 0, that is the initial position. Final positions, I use blue dots again, this is the final position. So when you look at the initial positions and the final positions, so it just takes 2 meter. So because of that, we say that the displacement is 2 meter. So displacement is hence just 2 meter. Displacement. Remember just the starting point and the end point, 2 meter. Okay, 2 meter to the right. 2 meter to the right. Or you can just put positive 2 meter. So we have to mention about the direction also. 2 meter to the right. Okay, so number 3. Speed is defined as the rate of change of distance traveled. Speed is a scalar quantity. The SI unit of speed is meter per second. So speed equal to distance traveled over time taken. So V equal to D over T. Okay, now let's say I use this as my example again. So let's say the object traveled 5 meter to the right and 2 meter to the left, and it takes, okay, let's say I add more information. So the durations for the object to move for this particular distance is, let's say, 10 seconds. 10 seconds, the duration is 10 seconds. And because of that, we can find the speed, which is equal to distance over time. Then you get 0.8 meter per second. So this is the speed. Okay, now let's move on. Velocity. Velocity is defined as the rate of change of displacement. Velocity is a vector quantity. The SI unit of velocity is meter per second, and velocity is displacement over time taken. So V equal to displacement over time. Okay, so let's say I use back this example again. So I want to find the velocity. I just take the displacement 2 divided by the time 10. So the velocity is 0.2 meter per second. So I put a positive here, showing that it is to the right. Okay. 0.2 meter per second. So you can see the difference. The difference is speed is distance over time, velocity is displacement over time. Okay, now let us look at number 5. For a linear motion means motion in straight line. So normally we take the motion to the right as positive, hence the motion to the left is negative. Normally it is like that. Okay, so the right hand side is positive, left hand side is negative. Okay, now let's move on. Okay, so example 2.1. The diagram below shows Tan running from A to B. So A to B, 50 meter. And then turning back to C, 10 meter. The total time taken is 20 seconds. Okay, so determine the distance traveled. Okay, so distance traveled 50 plus 10. So distance 60. 50 plus 10, 60 meter. Okay, part B, displacement. Displacement, we look at the starting point A and the end point C. Okay, so the distance from A to C is just 40 meter. AC, which is 40 meter. Okay, part C, speed. So we take distance divided by time. The time taken is 20 seconds. So we get 60 over 20. So we get 3 meter per second. Part D, velocity. So velocity we take 40 divided by time 20. So 40 over 20. So we get 2 meter per second. Okay, so that's the thing. Now let's move on. So we finish everything here. Next page. Acceleration. Acceleration is defined as the rate of change of velocity. Acceleration is a vector quantity. The SI unit of acceleration is meter per second per second. Okay, so acceleration, I give one example. If an object is moving faster and faster, then we call it accelerate. If the object is moving slower and slower, for example, when the car is braking and then it is moving slower, so we call it decelerate. So that's the idea. Okay, so the formula, A equal to V minus U over T. So A is acceleration, and then V is final velocity, U is initial velocity, T is time. Okay, so this is the formula for acceleration. Okay, let's see more information. An object moving with decreasing velocity is said to be decelerating, and the value of this acceleration is negative. So when you count the A and you get a negative value, that means it is decelerating. Okay, now let's see one example. A motorcycle moving with a velocity of 2 meter per second. So this is the U. So initial velocity. Okay, so I write it down first. U equal to 2. Reaches a velocity of 16 meter per second. So 16 is V, the final velocity. In 4 seconds, the T is 4. So what is the acceleration of the motorcycle? So we use this formula. So V is 16 minus with U, which is 2, divide by 4. So we have 14/4, 3.5 meter per second per second. So that is acceleration. So you get a positive value. That means the motorcycle is moving faster and faster. So as you can see here, from 2 at the end, 16. It is moving faster and faster. Okay, so let's move on. We have ticker timer now. A ticker timer is an instrument to study the motion of an object. Okay, ticker timer. So what happened is, you can see, I zoom in a bit. Okay, you can see a ticker tape. Okay, a ticker tape. And this is the ticker timer. This part is a ticker timer which connect to a power supply. So what happened is, when you turn on the electricity, so this particular part, you can see is like a needle which is pressing the ticker tape, will start to move up and down. So when the ticker tape is pulling because of the motion of an object, so this particular part will put dots on the ticker tape. And we have a fixed timing. That means in 1 second, this part will form 50 dots. So 50 dots. 1 second, 50 dots. Okay, so that is how fast the thing moves. And we have to use this information to study the motion of an object. Okay, so can you imagine or not how it works? Yeah, okay, so you see the information here. A ticker timer is used to study the linear motion of an object. It consists of an electrical vibrator which vibrates 50 times per second. The ticker timer makes 50 dots per second, something like this, dot. Okay, make 50 dots in 1 second. It's quite fast. So on the ticker tape being pulled through it. So you pull the ticker tape through the ticker timer, and then you can see 50 dots. Okay, so now we have to think about it. In 1 second, it makes 50 dots. So the time interval between two adjacent dots, that means two dots that are next to each other, that is called adjacent dot, on the ticker tape is called 1 tick. So this is 1 tick. You can see 1 tick. 1 tick is the time interval between two dots. So 1 tick is equal to 1/50 second. Why 1/50? Because 1 second, 50 dots. So the duration it takes from here to here is 1/50 second, and which is 0.02 seconds. So we can find out the time based on the ticker tape. Okay, now let's see example. Find the number of ticks and the time interval between the first dot and the last dot on the ticker tape below. The frequency of the ticker timer is equal to 50 Hertz. So what is meant by 50 Hertz? 50 Hertz means in 1 second, 50 dots are made. Okay, so now we look at the ticker tape over here. Okay, so you can see the first dot. This is the dot, So there are 1, 2, 3, 4, 5, 6 dots, and the tick is here to here, one tick, one tick, one tick, one tick, and one tick. Okay, so the first part of the question, they say find the number of ticks. So 5 ticks. Number of ticks 5. The time interval between the first dot and the last dot. Okay, so the time interval okay, so we know that each tick is 0.02 second. So now you have 5 ticks. So the time is 5 times 0.02, which is 0.1 second. Okay, so this is the time span to make so many dots. Okay, now let's move on. Okay, so imagine the ticker tape is held by an object which is moving. So it held by a trolley, for example. So the trolley is moving slowly, for example. Okay, you can see here, if the object moves slowly, the dots are close to each other. If the object moves quickly, the dots are far apart. So they are far apart because the object pull the ticker tape quickly, and it make a greater distance, okay, in 0.02 seconds. So that's why the tick is, the two dots are like far apart. Okay, now let's see the next page. So this is the one. So if your ticker tape look like this, that means the object move with lower speed. If the ticker tape is making a greater distance between two dots, that means the object move with higher speed. Okay, so now let's see this part. Analyzing ticker tape. Okay, so you have directions of motion. Direction of motion is to the right. That means the trolley, let's say for example, the ticker tape is stick to a trolley, something like this. You have a trolley. Okay, this is a trolley. So it's held by a ticker tape. This is the ticker tape. And then imagine your ticker timer is here. Okay, so this is moving up and down and make dots on the ticker tape. So if the trolley is moving to the right, you should expect initially this particular part, the needle part here, we'll put dots over here first. The dot here form first, and then they keep moving to the right, and then the dot on the right form at the end. So the dot on the left form at the end. So the dot on the right is the first dot. Okay, so this is the first dot. This is the last dot, if the motion is like that. Okay, now you have uniform velocity. You should expect the distance between dots is the same. And of course you may have a very long ticker tape, and you can just put 1, 2, 3, 4, 5 ticks as one ticker tape, and then you cut, and then another 5 ticks as another ticker tape. So you will find that they have the same height, showing that it is uniform velocity. Okay, so now next one. The distance between the dots is equal. You can see same distance, same distance, same distance, and same distance. All the strips of the tape in the chart are of equal length. So same length, and this is uniform velocity. Okay, so now let's move on. Uniform acceleration, so which means it is getting faster and faster. So remember that the first dot is here, the last is here. So initially you can see they are moving small distance, and then the distance is getting larger and larger, so showing that the object is moving faster and faster, in other words accelerating. So if you put them in this chart, so you will see the, they are taking 5 ticks for each ticker tape. So the 5 ticks is getting higher and higher, so showing that they are faster, the object is moving faster and faster. Okay, now A, the distance between the dots increases uniformly. So increases uniformly is like, you see, increase 2 cm, then increase 2 cm, then increase 2 cm, then increase 2 cm. So increase 2 by 2 cm. Number 3, uniform deceleration. That means it is slowing down. Okay, so again, remember the first dot is here, the last is here. So that means initially they are very fast, then they are slowing down as the distance is getting closer and closer, so they are slowing down. So initially far away, and then at the end close together. So from fast back to slow. So the distance between the dots decreases uniformly. That's the first thing. The second thing, B, the length of the strips of tape in the chart decreases uniformly. So decreases. Okay, so finish. Next one. Now we have activity 2.1. Determine the displacement, velocity, and acceleration of a trolley by using ticker tapes. Okay, so we look at the picture first. So what we need to do is we need to put the trolley in an inclined runway. That means a runway with particular angle. So there is a ticker tape that hold at the back of the trolley. Okay, passes through the ticker timer, and the ticker timer will make dots on the ticker tape. So you let it go down, and then you want to study the ticker tape. From the ticker tape, we are able to calculate and find out the displacement, the velocity, and the acceleration. So we want to understand that. Okay, so now let's see the aim over here. To determine the displacement, velocity, and acceleration of a trolley by using ticker tapes. Apparatus, we have trolley, runway, ticker timer, AC power, supply, cellophane tape, and wooden block. Material, we have ticker tape and connecting wires. Okay, so procedure. Okay, let's see. The runway is inclined until the trolley can move down freely when it is released. 50 cm of ticker tape is passed through the ticker timer and attached to the trolley. The ticker timer is turned on and the trolley is released. That means initially you hold the trolley with your hand, then you turn on and then you release your hand. Then the trolley will move down, then there are dots at the ticker tape, then you just study the ticker tape. So results. Ticker tape below is obtained from the motion of the trolley. Okay, so you can see direction of motion is this way. That means the first dot is here, the last is here. So initially they are slow, so that's why they just make 0.5 cm. At the end they are fast, that's why they make a 3 cm. Okay, Now we want to count the displacement, the velocity, and the acceleration. Okay, so let's see the calculation here. We have initial velocity. So you want to count initial velocity, you have to look at the first part, 0.5 cm. And we know that this is one tick. One tick is 0.02 second. So that's why if you see the working here, you can see 0.5 the displacement divided by the time 0.02 because of one tick. Then you get 25 cm per second. Final velocity, so you look at this part, final velocity. So the displacement here is 3 cm. The time is 0.02 seconds, so you divide and get 150 cm per second. Something special about this is the time. The time between the final and initial velocity, t equal to 6 minus 1 ticks. So this is a bit special, you must remember. If you see how many ticks we have 1 tick, 2 tick, 3 tick, 4 tick, 5 tick, and 6 tick. So we may easily misunderstand that if there are six ticks, so we take 6 times 0.02 as the time, but at the end it is not. It is not. So if you see what they do here, the time is 6 minus 1 ticks. We just take 5 ticks, not 6. Okay. Less 1 tick than total number of ticks to determine the time taken for the change in velocity. So what are they trying to say here? So I can put it in this way. The reason why we take 5 ticks is simply because the initial velocity that we count here, 25 cm per second, happens at this point. 25 cm per second happens here. It happens at that point. Okay, so it is not happens at this point. Maybe at the beginning it's not moving. Should be 0, should be 0. Okay, so that's why we don't take this point as the initial velocity. It reached the velocity of 25 cm per second at this point after 0.02 second. So that's why we take here. Okay, then after that, the final velocity is 150 cm per second. It happens when the last tick finish. That means at the end of the last tick. So at this particular point, it achieved 150 cm per second. Okay, so if you look at the durations from here to here, so this is 5 ticks. So that's the reason why we take 5 ticks, not 6 ticks, just 5. Okay, because the initial velocity happening at this particular point of time. Okay, so 5 ticks. So remember the reason. And they take 5 ticks, then the time is 5 times 0.02, which is 0.1. Then you count the acceleration, v minus u over t. So you get the acceleration 1250 cm per second per second. So that is the acceleration. Okay, so we get the accelerations, and okay, so this experiment finished already. Okay, so of course maybe you are wondering, how about displacement, velocity, and acceleration. Displacement, you just need to count the length from the first dot to the last dot. You measure the length and then you get the displacement. Velocity, it depends. If you want initial velocity, this is the one. If you want final velocity, this is the one. So velocity has been counted. Acceleration is here. Okay, now we see discussion. The distance between two dots increases uniformly. So you can see, increase greater and greater. Thus, the trolley moves with uniform acceleration. And this is the acceleration. Okay, so let's see the next page. Okay, so now we have an example. Example 2.4. A trolley is moving up a slope. Moving up a slope, you should expect it to be slower and slower. So that's why you see this is shorter and shorter, showing that it is decelerating. The above diagram shows a ticker tape chart for the motion of the trolley. And then every section of the tape contains 5 ticks. So you can see 1, 2, 3, 4, 5. 5 ticks. Okay. If the ticker timer produces 50 dots per second, that means one tick is 0.02 seconds, which is 1 over 50. Determine the acceleration of the trolley. Okay. So the acceleration's formula is A equal to V minus U over T. So you want to find U, you look at this, the first bar, and you want to find V, you look at this one, and then the time we discuss afterwards. Okay, now let's start with U first. Okay, so U, you see the length is 5 cm, so 5 divided by the time. So the time, we have 5 ticks over there, 5 times 0.02, then we divide, we get 50 cm per second. Okay. Then the V. For the V, we look at this, the last bar, and the length is 1 cm. So 1 divided by the same timing, as there are 5 ticks also. 5 times 0.02, so we get 10 cm per second. Okay, so we have U, we have V. Now the time. So just now we said we need to cancel off 1 tick. Now for this case, are we going to cancel off 1 tick, or are we going to cancel off one whole bar? Okay, so for this case, remember, we have to cancel off 1 whole bar. Okay, so that means we don't want this. We don't want this whole bar. Okay, so the reason is because the velocity of 50 cm per second happens after the 5 ticks. So that's why we don't want the first 5 ticks. So we just want 1, 2, 3, 4. We just want 4 bars only. Okay, we just want 4 bars. Okay, so each bar is 0.1 second. 0.1 second. So because of 5 ticks, 5 times 0.02, we get 0.1 second. So we have, you see the time span, 0.1 second, 0.1 second, 0.1 second, and 0.1 second. So 0.4 second altogether. So we cancel off the first whole bar. So the time is 4 times 0.1, which is 0.4 second. So make sure you remember the reason. The reason is the velocity, the initial velocity U, which is 50 cm per second, happens after the first bar finish. Okay, so that's why we have to take time after the first bar. Okay, so now we count the acceleration. V minus U over time. Negative 40 over 0.4. Negative 100 cm per second per second. So you have a negative value, that means it is decelerating. Decelerations is deceleration is 100 cm per second per second. You see, when I say deceleration, I remove the negative. Okay, deceleration already means it is slowing down. So that's why when I put acceleration, I put negative. When I put deceleration, I don't put negative anymore. It already means negative.
Let us look at activity 2.2. Determine the velocity and acceleration of a trolley by using a Photogate system and electronic timer. Okay, we look at the aim first. To determine the velocity and acceleration of a moving trolley by using a Photogate system and an electronic timer. So maybe you are wondering what is Photogate system and electronic timer. So let's look at the pictures to understand more on this. So first of all, we put a trolley on a runway. So the runway is inclined so that the trolley will slide down. And there is something on the trolley where, if I zoom in a little bit, then you can see that there is a piece of plate which is known as shutter plate here. So this is shutter plate. The usage of shutter plate is to block the light. It blocks the light when the trolley moves through these Photogate. So this Photogate, there are lights moving from here to here. Okay, so the light is moving from here to here, but when the trolley passes through the first Photogate, it blocks the light, and at that moment the electronic timer will start calculating the time. Okay, then the trolley continue to move down, and when it reach here at the second Photogate, again the shutter plate is going to block the light in the second Photogate, and the electronic timer will stop the time. So in that situations, we can accurately find out the time taken for the trolley to travel from this point to this point. Okay, so this is more advanced compared to the previous experiment which used ticker timer, because for this kind of setting, the trolley will have no frictions when it moves down the runway. Okay, so not like ticker timer, the ticker timer, when they want to make dots on the ticker tape, so it creates frictions. Okay, so this one is the better design. Okay, now let's see the information. Apparatus, we have a Photogate system. So the first Photogate and second Photogate, that's the Photogate system. Electronic timer, this is the one. Trolley, okay, and then the runway, and the height adjuster. Height adjuster is here. Okay, now let's see the procedure. The apparatus is set up as shown in diagram 2.9. Okay, so you can see the diagram over here. Now let us continue. Number 2, the height of runway is adjusted to 15 cm. Okay, then the separation between the two photo gates S is adjusted to 40 cm. So remember, the separation between the two photo gate is basically the displacement of the trolley. The displacement of the trolley is 40 cm. Number 4, the electronic timer is turned on, the trolley is released and is caught after it passes through the second photo gate. So we catch the trolley after it passes through the second photo gate so that it doesn't go to elsewhere. Okay, so number 5, the time taken T is recorded. Okay, so the time T here is the time, like what I explained just now. The first photo gate will start the timer, the second photo gate will stop the timer, and hence the T here is the time taken between two photo gate. In other words, it is the time taken for the trolley to travel by 40 cm. Number 6, the first photo gate is removed. Okay, now we remove the first photo gate. The second photo gate remained. Step 4 is repeated. So you see step 4 again. The electronic timer is turned on. The trolley is released and is caught after it passes through the second photo gate. Okay, so now you don't have the first photo gate. So you release the trolley will go down the runway and they will reach the second photo gate. And what happened is the electronic timer will record down the time interval delta t. Okay, so what is meant by the time interval delta t? Okay, so first of all, we need to know that the trolley okay, you look at this point here. The trolley has a shutter plate of size 5 cm. Okay, have a size of shutter plate which is 5 cm. So that means this is the trolley. Okay, this is the trolley, and then we put the shutter plate here. This is 5 cm. Okay, so that means the shutter plate is going to block the light in the second photo gate when it moves 5 cm. Okay, so the duration span is known as delta t. Okay, so because of that, delta t is the time interval when 5 cm shutter plate blocked the light in the second photo gate. Okay, so that's why we have a second information here, which is delta t. Delta t is the time interval when 5 cm shutter plate blocks the light in the second photo gate. Okay, so the electronic timer is able to find out how much time is spent for the trolley to move 5 cm. Okay, so this is the usage of why we need to find out the delta t. We want to find out the velocity of the trolley. Okay, so we have 5 cm, we divide by delta t, then that is the velocity or final velocity of the trolley. Okay, so that's why you see the table here. Delta t is the time to travel 5 cm. 5 cm, so the per second, I just cut it away. Okay, so the velocity is displacement 5 cm divided by the delta t. So displacement over time, so that is the final velocity of the trolley. Okay, now let's see the next point. Step 3 to 8 are repeated with s equal to 50 cm, 60 cm, 70 cm, and 80 cm. Okay, so that means we separate the two photogates for a longer displacement. Okay, now let's see the results here. So we have the s of 40 to 80. So the t is the time taken between two photogates. So delta t is basically the time interval when 5 cm shutter plate blocks the light in the second photogate. So that is the delta t. And then you take 5 divided by delta t, we get the velocity. That is the final velocity. Okay, then we have acceleration equal to v over t. So what happened here is, first we need to know acceleration's formula is a equal to v minus u over t. But the u is 0 because the trolley is whole at the beginning. So that's why it has initial speed of 0. So u equal to 0 because you hold the trolley at the beginning. So that's why we have v over t. V over t, because u is equal to 0. And how we get the v? We get the v from this part. This is where we get the v, the final velocity. So v over t. So discussion. This method is more accurate compared to ticker timer and ticker tape method because no ticker tape is attached to the trolley. As such, the friction between ticker timer and ticker tape does not exist. The electronic timer can measure up to 0.001 second, whereas the ticker timer can only measure 0.02 second. This enables the short time interval to be measured accurately. So you can see it is more accurate. By using electronic timer, this is more accurate compared to ticker timer. Thus, the velocity and acceleration can be determined more accurately. Okay, so this is the experiment. Okay, so we have done this part.
Let's see here. Solving problem of linear motion using linear motion equations. Okay, so number 1, for uniform velocity. Uniform velocity means no acceleration. So when there is no acceleration, then we can use displacement equal to velocity multiplied with time. Yeah, this formula is something that we learned before, something like distance equal to speed multiplied with time. Yeah, so displacement equal to velocity multiplied with time is just similar. So you can get this. We can only use this formula when there is no acceleration. For uniform acceleration, displacement equal to average velocity over multiply with time taken. So you end up the velocity, then you divide by 2, that is the average velocity. Then you multiply with time, and then you get the displacement. So the difference between number 1 and number 2 is, number 1, no acceleration. Number 2, we have a constant acceleration. That means acceleration is equal to a number, a fixed number. And then you have to use difference formula to count it. So this equation involves SUVT. from the definition of acceleration, a equal to v minus u over t. This is our formula just now. If you rearrange it, imagine you bring the t over to the left, you get at. Then you bring the minus u over, you get u plus at. So this is the formula. V equal to u plus at. Okay, so the second formula. You see they put numbering. This one, the first formula. This one, the second. Now this equation involves VUAT. Okay, I explain it in this way lah. We have altogether SUVAT, 5 quantities. SUVAT, we call it SUVAT. Okay, the first formula, this one, SUVT. We use this formula when you don't know the A, the acceleration. Okay, let's say I use small letter because acceleration is used in small letter for our notes here. So when you have no acceleration, we use the first formula. When you have no S, then you use the second formula. Okay, now substitute equation 2 into equation 1. So imagine equation 2, this one, substitute into equation 1. That means this V is replaced by U plus AT. So you can see here, U plus AT. So U plus U, 2U times T, 2UT. Okay, let's say I work out half 2U plus AT times T, half 2UT plus AT square. Now divide by half, become UT plus half AT square. So that's why we get the third formula. So the third formula is used when we don't know about V. When you don't know about V, you see the whole equation have only the 4 quantities without V. So we use the third formula when you don't know V. Okay, then let's continue. Okay, this part. This equation involves SUAT, rearranging equation 2. Okay, so equation 2 is V equal to U plus AT. So you rearrange it, V minus U equal to AT, T equal to V minus U over A. So once you get this, then you substitute into equation 1. Equation 1 is S equal to 1 over 2U plus V times T. You substitute here. Okay, so when you substitute this inside, then you get this. The T is replaced by this now, and then you have V plus U, V minus U, you multiply, become V square minus U square. Then the bottom become 2A, and then the 2A you bring to the left is S, so it becomes 2AS. Then the minus U you bring to the left, it becomes U square plus 2AS. So that's why we have this formula, formula number 4. So formula number 4 is used when you don't know T, when there is no T given. So we have 4 formula altogether. Okay, so the conclusion is you see I put all the formula together from the beginning until just now, right? Okay, so the first formula is S equal to Vt. This formula is used when acceleration is equal to 0. When acceleration is not 0, then we have A equal to V minus U over T, or V equal to U plus AT. We have just now before this we have S equal to half U plus V times T. Okay, so we also have s equal to ut plus half at square. We also have v square equal to u square plus 2as. So we have 4 formula. Okay, so 4 formula for our syllabus. Okay, 4 formula. Okay, now let's see example 2.5. A bus is accelerated at 5 meter per second per second. So you have to write down the information given. A equal to 5. From an initial velocity of 4, so u equal to 4, for 10 seconds, t equal to 10. What is the distance traveled by the bus? Distance traveled, so that means the displacement. So we have s, u, a, t, we don't have v, no v. So the formula with no v is this one. No v, this one no t, this one no s, this one no a. So we have to choose the formula without v. Without v, we choose this. So s equal to ut. Ut plus half at square. So the u is 4, the t is 10, half, the a is 5, and then t square, 10 square. Okay, then after that, we just press calculator. 40 plus 100, 500, 250, 290 meter. Okay, so we get this. Okay, now another question. A car accelerates from 4 to reach a velocity of 24. Okay, so we know u is 4, v is 24, s is 50. What is the acceleration? Okay, they are looking for a. So we have u, v, s, a. We don't have t. When you have no t involved, so you have to use the last formula, v square equal to u square plus 2as. So v 24, u 4, 2, a is unknown, s is 50. So we just need to solve. 24 square minus 4 square divide by 2 times 50 divided by 100. So we will get acceleration equal to 5.6 meter per second per second.